Hi, my name is Raul Bianchi from Uruguay. I'm talking about how does Uruguay manage to vaccinate at high speed and with a constant flow with the application of TOC. As an introduction, the COVID-19 pandemic brought global challenge both for healthcare system and for the development of vaccines at an unprecedented speed to end the epidemic that has already led more than 3 million deaths. At the same time, the health urgency implied that the distribution of the vaccines was carried out on a global scale and simultaneously with scientific research in a work that was done in real time. The sum of all of these extraordinary conditions allow us to affirm that the COVID-19 pandemic brought with it the greatest logistical challenge in history. In November of 2020, the beginning of the distribution of vaccines to end the pandemic in all countries of the world was imminent, and in Uruguay, both the public and private sectors worked in parallel to define how they would distribute the doses in the country. What is this presentation about? I'm going to tell you how Uruguay, having started vaccination 3 months later after the first ones, is today among the countries in the world that have the highest percentage of vaccinated and are doing it very fast and did it very fast. As some environments and necessary conditions, Uruguay is a country in South America. It limits with Brazil and Argentina and has the Atlantic coast on the Atlantic Ocean. It's the second smallest country in South America, and it's about its size is about half the size of Japan. The population is about 3.5 million people, 19 departments. The capital and most populated city of the country is Montevideo, that has 1.4 million people, which represent 40% of the total. We can move to the next slide. As some necessary conditions, I see what are the necessary conditions that we need to reach to get the objective. One of these is the National Integrated Health System that provides universal access to all residents of Uruguay. This means that all people will have the right to a comprehensive service of homogeneous quality and under the conditions defined by the regulation of the law itself. It was one of the necessary conditions. The other is the experience and good history and adherence to vaccination campaigns, such as against the flu. As a result, Uruguay developed structure and coordination among the actors of the National Integrated Health Systems. Involvement of the presidency in the negotiation with Pfizer and Sinovac laboratories. The COVAX mechanism resulted an utopia, and the intelligence of the Uruguayan government was that without leaving it, they focused all its energy, international image, and context on achieving direct agreements with the pharma. These are all necessary conditions. We can move the next slide. But the one that gave sufficiency from my point of view was included TOC in the development of the plan. The environment and previous conditions were sufficient to carry out the national vaccination plan, developed up to the moment in December 2020 with the usual speed and process. At that time, it was planned to vaccinate about 80,000 people per week under high performance conditions. Considering that the target population is about 3 million, and that an adherence percentage was estimated of 70%, this would imply that Uruguay would take more than 1 year to vaccinate its population. That was that at December of 2020, the President of the Republic ordered that a consultant from private activity without experience in public administration be in charge of the logistics and the distribution of vaccines throughout the nation. Until that moment, my relationship with the President of Uruguay had consisted of some meetings where we talk about the foundation of TOC and its application to the business world. In the first week of January 2021, we determined that the objective has to be to vaccinate 70% of the target population with 2 doses in less than 5 months. The application of the 5 focusing steps with some basic concept of DVR, buffer inventory management and critical chain was complement or sufficient condition that allow us to achieve the objective. So let's get in the design of the national vaccination plan. We can move to the next slide. The first step is identify the constraint. And we were talking about different possibilities to have the constraint. But this was, when we consider improving a system, the first step is identify. On this occasion, in which we propose we design a new system, we carry out a working day to answer the question, where do we want the constraint to be? It was different from other applications because when I go to a system or business, the constraint is what it is. But in this design, we could choose where do we want the constraint. We decided where to have the constraint, and this choice implies that the distribution and vaccination capacity must be higher than the arrival rate of vaccines. We want the constraint of the system to be the number of vaccines we have in Uruguay. We can move to the next slide. This was the choice of the constraint, the amount of vaccines. It implies a lot of things. In this way, we ensure that we inoculate and protect priority group as quickly as possible, and the pressure for better performance comes from the executive, which is the one who negotiates with the pharmas the quantity and frequency of delivery. This was one of the implications of choosing the constraint to be in the number of vaccines. I told the executive, the president, and the secretary, you will have the pressure because the speed is going determined basically by how good are you negotiating with the farm. When the constraint is chosen, we ask, step 2, how do we obtain the greatest impact from each dose that reaches Uruguay? How do we ensure that the time that happens since the arrival until it is on the shoulder of the correct person is as short as possible? You can go the next slide. This is step 2. Perfect. And step 3, that is subordinate, was about how should we coordinate and align all the actors involved in the national vaccination plan to the decision of the previous step. To answer these 2 questions, I'm going to present in 2 groups, criteria and tactics of the solution. We can move one slide more. Okay, we're seeing the criteria and tactics. Have the necessary infrastructure to ensure stability and correct handling throughout the supply chain for the most demanding vaccine. This is from the reception at the airport to the vaccination center. Another one, ensure that all doses are used. Remember at this time, for example, with Pfizer, it was the issue that you can have 5 doses from each vial, or you can have 6 doses, and so the time that you have once you defrost it is only 5 days. It was an issue, so ensure that all doses are used. Another criteria is comply with the criteria for prioritization groups set by the Ministry of Public Health commissions of experts. They told us you have to vaccinate first this group, second this, third this. And the other criteria is to build a daily vaccination capacity that ensures a minimum of 1% of the population, but can be rapidly expanded to 2%. This flexibility and fast increase in capacity was necessary to ensure that the constraint remains in the quantity of vaccines arriving in Uruguay. I wanted to have the constraint all the time in the arrival of vaccines. We can move to the next slides to see the tactics. The first one is protective capacity. I think this is one of the concepts explains in the goal that, in my opinion, is the most difficult to understand. It is due to the fact that we assume that an idle resource is a waste, and in several implementations of drum buffer rope system in production, a difficulty that appears is understanding that to maximize the output and flow through the bottleneck, all the other resources must have enough capacity. Enough capacity to feed the bottleneck and to recover from Murphy and system fluctuation. So how much protective capacity should we have? It depends on the variability of the system. But my experience in these 20 years applying TOC in different countries in America with different customs has taught me that in general we are conservative. Faced with what kind of mistake we want to make, too much or too little protective capacity, we end up choosing to have little. Then what happens is that we fall short and the system does not reach its maximum potential. The project was planned in such a way that if we made a mistake, I wanted it to be excess capacity and not the other way around. To comply with the above criteria, and given the uncertainty that existed in January in Uruguay in 2021, regarding which vaccines Uruguay was going to have, in which quantities and in what time, we decided to create sufficient protective capacity throughout the supply chain, airport, distribution center, vaccination, that will allow to adapt quickly to the different scenarios. For example, the concept of protective capacity refers to the fact that the dimensioning of the infrastructure and process from the receptions of the vaccine to its injection must be carried out not based on an average demands, but on its possible peaks and valleys. This had an impact on the expenses, of course. Some expenses were able to adapt to this variability and others not. I'm going to tell you for 2 examples. One that could not be adapted, for example, was the storage capacity in ultra freezers, which was sized for the most demanding case. For example, 800,000 doses of Pfizer. In this case, it was not possible to have less ultra freezer, and in the face of the notice of a greater arrival of doses, to buy and install more. Delivery times were around 2 or 3 months and installation about 1 or 2 weeks. So we had more ultra freezer than needed. An example that was adaptable and flexible was the vaccination teams. The teams were designed in a multidisciplinary manner, which imply that capacity could be adjusted by reducing or increasing people, and the employment contracts contemplated payment for availability or presentism. If for a few days it was necessary to reduce the capacity, the person was notified so that they did not report to work, but they continued to earn a minimum for being available for when they were called again. In this way, that the expense was variable according to the demand. The workers had a motivation to be on call where they were needed again. This protected capacity tactic was designed in such a way that the vaccination flow was maximum and constant. I remember this presented an additional difficulty because it required the system to have the capacity to adapt to an irregular arrival of vaccines while maintaining an interrupted vaccination rhythm. The system had to be flexible enough to make the necessary capacity change to accommodate the vaccine supply, the constraint, but at the same time to ensure a constant flow. We can move to the next slide. This complication was due to the fact of one of the criteria: ensure that all doses are used. Given that the useful life of some vaccines, when defrosted, sent to the inoculation point in less than 5 days, having a discontinued flow threatened not only against the criteria, but also against meeting the prioritization criteria proofs set by the Commission of Experts. In the research carried out in other countries with Pfizer, we found that techniques such as Instagram or Facebook had to be used at the end of the vaccination day to quickly get clients to receive the vaccines before they expire. In short, maintaining a continuous flow ensured that several criteria of the solutions were met. The other one is the replenishment time. We have seen that in application of TOC, of distribution and inventory management, one of the key concept is the replenishment time. What is the replenishment time in this case? It's all the time that happens between the moment a dose is used to vaccinate a person at the vaccination center and the replenishment arrives from the distribution center. This time includes programming time, the time between a dose is taken in the vaccination center and the order of the replacement is sent to the distribution center. It includes the time the stock is informed, the analysis of the demand versus stock, and the quantity that is needed to be replaced at the vaccination center is programmed. The other component is the order preparation time, is the time between the distribution center receive the order and prepare it. And transportation time, the time that takes to transport and deliver the order once prepared from the distribution center to the vaccination center. The consequence of the application of this concept had as a result that the design of the process was in a such way that the time it takes between the first vaccination of the days given, the information arrives to the programming center, the needs are sent to the distribution center, a vial is thawed and reach the vaccination center is less than 24 hours. This allows the vaccination center to have an inventory to cover the daily demand, which minimizes waste and improves control. We can move to the next slide and see the last one is about the demand control and the variability. In order to ensure a constant flow, avoid waiting queues, and take advantage of the installed capacity, we worked with a waiting queue system. The system assigned the quotas according to the priorities set by the Commission of Vaccine Experts, the quantity of vaccines delivered to the country, and the programming horizon. The system allocated each 15 minutes the capacity of the vaccination centers. This mechanism allows continuously flow of clients through the process. This is about the criteria and tactics. We can move to the next slide. Okay, you are all ready. And see the application of critical chain to develop this plan. The project has 6 work packages, and the key one was infrastructure. That was the slow and critical step. That was where the greatest effort were concentrated and daily monitoring was carried out. The country did not have in the current distribution center the capacity or the equipment to store vaccine at -70 degrees Celsius, or to operate with dry ice if it was available. Initial inquiries resulted that Uruguay has lack of ultra-freezer capacity, and the shortest delivery time were about 60 or 90 days. Definitely, he was the critical chain of the project, and it was where the greatest efforts were focused. The project team only managed a due date. We had to be ready for February 21. Some comments about that, we can move to the next slide, is that we'll go back, I think the next one. Okay, and one more, please. We're going down, sorry. Back. One more. Perfect. Okay, we only manage one due date, February 21, focus on work package infrastructure, just one buffer, the project buffer. We have no middle task. We don't have another date to achieve this one. And the follow-up meetings where a task is finished or not. We don't measure progress. I'm about 50% of the task. No, we don't use this kind of management. It's a task is finished or is not finished. And we are focusing on the critical ones. The other ones ask for help if any obstacles appears. If not, we assume that you are working well with the task. The participation of actors from the scientific community, such as the Honorary Scientific Advisory Group, who provided the link with scientists from, for example, Israel and Argentina, who provided their experience, was of a great help. The collaboration of these scientists was key to avoid making mistakes. Israel was, at that time, one of the countries that was vaccinating the most with Pfizer worldwide, and having its recommendation firsthand, as well as its learning, was something that shortened the project deadlines significantly. The same with Argentina, a country where Pfizer has done the study of phase 3. Finally, on February 21, Uruguay was prepared to start to vaccinate 40,000 people per day, more than 1% of the population. And the first vaccines arrived on February 26. It was a great date for all Uruguayan people, and it was very celebrated. We can move to the next one. It's a picture that we all remember, the airplane LATAM arriving with some help of the government of Chile, arrived this day. And we knew at this time something about the program and the agreement with the laboratories. We can move to the next one to see the amounts and the arrivals of Sinovac, with a purchase agreement of 750,000 doses, and Pfizer with 2 million doses. The flow through the systems worked correctly and smoothly, detecting an unforeseen bottleneck in the scheduling system. In the month of February, several tests were carried out. In this opportunity, the scheduling system gave a warning when it was subject to a stress test, and the implemented solution would demonstrate in practice that the problem would persist. It was necessary to change the scheduling process to a waiting queue system provided by an IT company in direct collaboration with the presidents and the electronic government. This allowed the system to regulate the flow of scheduled people and to give them a date and time as the availability of the vaccination centers opened. The detailed scheduling horizon was 1 week. It was very important to adapt to change in the environment and new discoveries and scope and applicability of vaccines. It was a really, for me, was a very hard point of agreement because everybody want to schedule 1 month or 2 months and give all the people exactly the day and the hour. And I said, we can give them an estimate, but the program, scheduling program, is no good that be more than 1 week because we are not going to be able to adapt to the changes. And for example, 1 week Sinovac, if you were older than 70 years, you cannot have Sinovac, and 2 weeks later, they show new results. Okay, now these people can be vaccinated with the vaccine. So it was a very important key about the program. What about the results in the first 3 months of vaccination? We can go to the next slide. This graph shows us Uruguay ends the month of May with very good vaccination results and with a general perception of a very good performance. The comments, both in the network and in the press, in the people, is of a system that flows incredibly fast and secure. Comments of the type, I arrive, I register, and the vaccinated me right away. What a good organization. And in this graph, you can see how, when there were vaccines, we vaccinated at maximum speed, and the valleys below, validating the fact that we designed the constraint so that it was at the rate of the arrival of vaccines. This graph shows that the first weeks, when we have few vaccines, we vaccinate few people, but when we get many vaccines, we use all the capacity, and there was some weeks that we vaccinate at the rate of 2% of the population daily. Then we get with few vaccines and the rhythms go down. So the system could adapt it to the constraint we choose, that was the speed that the vaccines arrives to the country. We can see the next slide that shows that constantly Uruguay maintained the speed of more than 1% of the population daily. It was, for me, it was important to maintain it because there were some countries that some day vaccinates a lot, but the other days go down. So the speed and the amount was very important to maintain it during the time. And in the next slide, please, we can see at the end of July, we started in March, April, May, June, July, 5 months. In 5 months, the objective we put is to vaccinate 70% of the population in less than 5 months. And when we're talking about 70%, is 70% of the objective people, not all the people in the country. And this graph shows that Uruguay at the end of July reached with 2 doses 64% of all the population and 74% with 1 doses. Was very important, this speed, because the pandemic in Uruguay was very well controlled, but just in the moment when the vaccines started to arrive, we have a second wave, and it was the 2 or 3 months that it was very not under control, the pandemic, and we bet that if we vaccinate quickly and fast, we could stop the rate of deaths and the pandemic, and it really works. In June, the situation was under control, and now we are practically all the country in green by the indicator of Harvard. Okay, I think there was an overview of thank you of what we did in Uruguay. I think one of the important thing is that for the first time, all the professionals and scientifics, no matter the political orientation, contribute to the country in this pandemic. I'm really glad that I could contribute with my expertise and the application of TOC of this vaccination plan. Thank you very much. Have a good day.
Thank you very much, Raul. Great. I will let you know once I release the video, and when they schedule the club, it can be in a few months' time. They have the schedule of their clubs running. So, but I will let you know the moment it happens. Thank you very much. I'll close the meeting now.
Okay. How do you see it? Good?
I think it's good. Yes. Thanks.
Okay.
Have a good day. I'll let you know when we are rolling it. Take care.
Yeah. Keep in contact.
Of course. Perfect.
Bye bye.
Thanks. Bye bye.
Ciao.